Weiss is going to come up and sort of talk about what has happened in our latest mission. And then Jens Vickert is going to bring up and sort of talk about and present a series of lectures from an outside perspective, from outside of the US. Jan?
All right, thank you, John. And I also want to build on the last talk that Eric gave and the comment that John just made. I also really appreciate the role that I think is for Cosmic-2 maybe a little bit less known and less appreciated. But without the help of NSF and Eric to do things like MIPR and make sure we could obtain and purchase instruments and various things in coordination with the other agencies. I'm not sure we would be at the 5-year anniversary of Cosmic-2 at the moment, at least on the US side. So that was hugely helpful. So this is a little bit different talk than the others. Cosmic-2 launched on June 26, 2019, roughly 5 years ago. So that's a nice anniversary. And it is still active and operating and producing data all day today while we're sitting here. So I'll actually have a little bit of results and also a bit of a look back, but obviously it's much more current. So, okay, so that's an outline. Here's some nice pictures from, this is a little bit before launch. So here we have the 6 spacecraft and some others on the launch stack. This was an Air Force STP-2 launch, a Falcon Heavy, was very cool. And there's a big team here from TASA, NSPO in those days, and a UCAR person, Elliot, who were supporting over many weeks the integration with the launch vehicle and the testing and making sure that all that would go smoothly. This is a really nice close-up picture of one of the spacecraft, and you can see here the RO antennas. There's these are phased arrays. There's one on each side. Here's a POD antenna. That's a choke ring. This is the RF beacon, which you can pick up signals from on the ground, and the IVM is actually on this other side, so you don't see it here, but really nice, nice photograph. And these are just a couple of videos just to give you an idea of the scale of this undertaking. It was really a massive thing. Not too many people got to see this up close, but you can just tell how what a neat technical and engineering achievement this was. And some photos of the launch here. So it's a Falcon Heavy. It launched a little bit late. It was supposed to go on the 25th, and it went early in the morning of the 26th. These are some photos from NASA. And again, it was the Air Force STP-2 mission. For those that were there, I think that was an unforgettable experience. The night turned into day. Really, really cool. And thankfully it went well. Of course, we were all quite nervous about that at the time, as is anyone probably, going into a space launch. This is a sort of long exposure picture here. You can see the rocket going up, and the 2 boosters actually successfully came back and were used again. So that was also remarkable. And then this is a portion of a nice video that TASA has put together from the Operations Center that you can see playing there on the right. And that's the first contact with one of the Cosmic-2 spacecraft. And that was a big deal. That happened, I forget exactly, an orbit or 2 after release. And of course, the TASA team and Suri and others were in Taiwan. And this is one of the Taiwan command and downlink antennas that was used. And a lot of us here in the States stayed up during the night and were on a phone net listening to this, and it was tense. And then this happened 6 times, right? So that was a big deal. And I just want to take this opportunity while we're here to call out the TASA team and the spacecraft operations. They have worked very hard and very smoothly over the years operating and maintaining this constellation. So it's been a great partnership, and they've put a lot of effort into making this go well in the last 5 years. So then some local pictures. You actually saw a picture earlier that was a little bit similar from Cosmic-1, and this is some moments from Cosmic-2. There's a lot of the same people. So we spent a lot of time before launch doing seemingly endless simulations of the system. Maggie and others will remember this. It was frankly rather painful at times. But we got to more and more high fidelity simulations of the end-to-end system, so that when the data actually arrived, it remarkably pretty much just worked. And credit to the entire team that involved ground stations and payloads and processing, all kinds of players. So that was a complex process. And so on our side, we got the first profiles. This is our first profile. It was a GLONASS profile, also a bit south of Hawaii, 3 hours within of getting the first data delivered. And it ended up being about 200 profiles that day. And of course, things went on from there. And I want to make a note here that our colleagues in Taiwan, who also have a processing system at the Central Weather Administration, they also have not only a processing system, but a time zone advantage. So they actually did this before us, but I don't have the plot. But I definitely want to mention they actually produced the first Cosmic-2 profiles. And then you've seen some pictures like this as well. We had a nice little get together that afternoon. You see a lot of familiar faces here. We had a team from UCAR and JPL and Aerospace and NOAA together for a while after the payloads were turned on to get through the checkout and initial commissioning. And later on, we went into CalVal. So that was a fun day. So neutral atmosphere products. I think this is all very familiar to a lot of this audience here. We've been talking about these since 2019. Actually, at the IRWG that was in Denmark, that was fortuitously timed. We were able to show some of the first results somewhere here in this time series in the early part of the mission. And this is pretty current through just a couple of days ago. And of course, we have high density coverage within about plus or minus 40 degrees latitude. I just want to mention something neat scientifically that Cosmic-2 is able to do. So, JPL has developed a very solid instrument that has a beam-steered antenna that allows high-gain tracking, and that enables duct detection fairly reliably and consistently. Sergey has published a nice paper earlier this year, and this is just a couple of plots from that. This is 2 years of data of ducts detected. The colors in the top plot relate to the estimated height of the ducting layers. And then down here is a comparison of what the ECMWF model predicted for ducting and what the data says. And they generally match very well. But I think the data can hopefully in the future foster research in this area that will hopefully improve what some of the models are able to do going forward. So I think there's a lot that can be done here. This is still relatively early work. Okay, so a little bit actually, now we're going to switch to space weather. So Cosmic-2 is at least as much a ionosphere space weather mission as it is a neutral atmosphere mission. So you can see here, I'm not going to go into a lot of details, but a number of products related to ionosphere here. So the first that were validated and put into operations were electron densities and then absolute total electron content, which was for the first time, I think, for both GPS and GLONASS validated to 3 tech units accuracy. That was a extensive process involving an extensive team here that is listed there. More recently, over the last couple of years, there have been a number of products in the area of scintillation and scintillation characterization and monitoring that have become operational. And I would just also credit the team at JPL for the foresight and basically a lot of this was not in the original requirements, but people had some thoughts about things you might be able to do if you can collect and downlink high rate data that would allow you to do some of these things, and that has turned out to be it's really delivered more than what was planned in a number of areas. So and so this sensor over time has continued to improve and gain capabilities that have allowed these products to be developed. The bottom one here is the ion velocity meter. I'm not talking about that today, but it is operating, and the team has worked a lot with the University of Texas, Dallas to develop a processing system for those data. So scintillation geolocation is something that's been a focus over the last couple of years. So basically taking these high rate data and both UCAR and Boston College developed algorithms to geolocate not only tell that there's scintillation along the link, but also estimate where it's happening. And those algorithms were extensively compared between us, and that actually was a very valuable process. Everybody learned a lot from that. And so on the left here, you see just a sample day from back in 2021 showing the geolocations, and they tend to happen in the early part of the local evening. On the right, we have monthly density plots of the geolocations in 2021 and 2023. So a year with lower solar activity, and then last year with much higher solar activity. And you can see pretty big differences, right? So these, we're clearly characterizing the state of the irregularities in the ionosphere here. And this makes sense. And this gives you information both about sort of the longer term trends and the morphology of the irregularity structures, but also near real time information, as is maybe demonstrated here. And those geolocations, speaking of near real time, go into a product called a plasma bubble map. And this is an algorithm developed by Boston College that we have operationalized here at UCAR. And you can see here, so basically this takes the information from the geolocations that is produced in near real time, along with information about the physics of the Earth's magnetic field and how plasma bubbles propagate to come up with this map that is now produced every 15 minutes. And it's giving us global information about the state of these irregularities. And as no one has challenged this. I don't think any other system can produce this kind of information currently at low latency and globally. So it's a pretty neat development. All right. So in summary, I think I've covered all of this. Cosmic-2 is, thankfully the launch went well. The spacecraft are operating. The instruments operated right at the beginning and have gained, in particular for TGRS, continuously improved capabilities. So again, for example, in these areas here to develop new products. There's a new capability back to the neutral atmosphere side that is just about, people are just about to get some sample data. So all satellites, as of a couple of weeks ago, are also collecting Galileo RO occultations for now on the setting antenna only. And in the future, it should be on both antennas. And that will add something like currently it's adding maybe 150 or so occultations per spacecraft per day, in addition to what we already have from GPS and GLONASS. And I think that'll increase a bit more once we have both antennas, of course. And these data are looking reasonable. We're just doing some validation, and then we'll be contacting some of our NWP friends to test that as well and make sure they're happy with those data. So that is, again, just a testament to the capabilities of the instrument and the ability to improve it with software updates over time. So happy 5-year anniversary to Cosmic. And this last slide is maybe the most important one. So you can see this is probably not everyone, but I think all the key partners that have been involved in making this happen. We, of course, have the lead agencies, TASA on the Taiwan side, who are responsible for the spacecraft and the operations. And then also our friends at Central Weather Administration for processing. We have NOAA and the Air Force/Space Force on the US side, and the various partners down there. And it's complex. It's a complex partnership, but it's proven to be, I would say, both nimble and effective over time. And that I think connects to one of the themes that we've been hearing all afternoon. That really comes down to a lot of very dedicated people who care about this and who have pushed this forward and cared about making this happen and be successful. And there are many, many challenges, of course, which I'm glossing over right now, but it's proven to be quite successful. And we hope we'll operate for many years in the future and produce these data and then some new data types as well. So I'll leave it there, and thanks for your time. So. Probably just go to the next session, right? Since we're kind of okay. Yeah. Oh yeah. So point it here. And you want
Yeah, okay. So we have a block of 5 presentations now, and that is summarized under the label of outside perspectives. But I want to really say